Hello, today I am going to share with you about the up counter in Allen Bradley PLC RSLogix programming. Okay, let me open a new file. Okay, I close this file and then I create a new file and then make sure the driver selected is Emulate 500 and click OK. Let me create few runs and then insert new instructions. Here I put the virtual switch. Alright, and some virtual switch. Maybe this one I don't need. Try to make it simple, and then I click this timer or counter tab. Okay, then I click this count up, mean up counter. Okay, then I need to give a name. Okay, for this I will give a name binary 3 column. Okay, word 0 / bit 0. Maybe this one I will use house input as my description, and then counter. Again, if you don't know how to write the address, you can refer to the data files. Here the counter is start from C5. You can double click this one and then refer to here. Okay, you can type C5 colon 0. Okay, so C5 colon 0. Okay, preset is our set point. Maybe here I can put 5. Okay, accumulated value is 0. Okay, this one I will use this counter address. Okay, you can double click this counter data file and then maybe I use a done bit. Okay, I click here, I can drag to here, or I can just type C5 colon 0 / done bit. This is a done bit. Okay, the output I will use this. Okay, maybe I will use digital output column word 0 / bit 0. So this one maybe I'll say like 0. So then I will compile a file to make sure there is no error by clicking this verify file and then click this verify project. There's no error, then I click here, select download, and you can save your file into your hard disk in wherever directory that you want. Here maybe I will, you can give a file name. All right, so I will say this is a up counter. Okay, save, yes, yes, and then click here again, select run so that the program can run. Okay, so maybe I put counter here and then I put the binary data file here. Okay, so you can either, this is a b3 colon 0 / 0. So b3 colon 0 / 0. You can click here and then key 1 to activate this virtual binary switch, or you can click here, right click, select toggle bit in order to trigger it to close. Okay, let's say you can choose whatever way that you want. How this program works is, when you trigger this switch to close, the virtual power will flow through this run to energize this up counter, right? So once it is energized, this CU or up counter bit will be activated. Okay, so if you continuously supply pulses to energize this up counter on and off, what happens is this accumulated value will increase. Once the accumulated value is increased and then equal to preset value or higher than this preset value, the done bit will be activated. Okay, so in summary, no matter which counter you use, up counter or down counter, as long as the accumulated value is equal to the preset value or higher than the preset value, then the dump bit will be activated and vice versa. Meaning, in other words, if the accumulated value is lower or lesser than the preset value, the dump bit will remain deactivated. Alright, so I will continuously generate the pulses in order to energize the up counter on and off until the accumulated value equal to the preset value. This dump bit will then automatically activated, and this activation will cause this virtual switch to trigger from normally open to close, and then you can see this virtual output coil will be energized. Okay, so I can click here and then right click toggle bit. You can see what happened to the CU and the dump bit. Okay, you can see the up counter bit is activated. Why? Because the up counter is energized. The dump bit is not activated because the accumulated value is lesser than the preset value. Okay, let me off it. Okay, this is one pulse, second pulse. All right, third pulse. All right, I can click here also and then type 1. Okay, 4 pulse, and then I can type 0, enter. 4 pulse. Okay, see what happened. Now the 5th pulse. See the dump bit. Okay, type 1. Okay, you see the dump bit is activated and trigger this switch from normally open to close. Hence energize a virtual output switch. And this will cause the external load. In this case, is a light 0 to be activated, meaning to turn on the light 0. Right? So what happened is if I continue to toggle it, see what happened. See, it will increase again. So if I toggle again, it will increase. The accumulator value will keep increasing, and the dump bit remain activated. Why? As I said before, when the accumulator value is equal or higher than the preset value, the dump bit will be activated. If let's say I want to reset the accumulator value, if you see here, it will not be reset to 0, the accumulated value. See, it not reset to 0. So what we should do is maybe I go offline. Okay, and then I will create another round, and then I go to timer or counter tab, and then I will select reset. Okay, I select reset, and then maybe I put one input here. Okay, maybe I copy another instruction here, and then this one maybe I change to bit 1, and then I will say this reset pulse. Okay, once I supply a pulse to here, okay, this reset I need to put an address, so I will put this address to here. Okay, so once I supply a pulse to this round, it will energize this reset and thus cause the up counter with the same address to reset its accumulated value to 0. Okay, let me compile the file to make sure no error, and then click this one to download, click OK, and then click here again, and then click run. Okay, let's say I toggle again, it increased. So I want to reset accumulated value. What should I do? I click here, I toggle. See, it reset to 0. Okay, so that's it. Thank you.